that's what they are. Okay, so what we're going to talk about today is we are going to talk about how to set up a system using a word problem, okay? And what we're building towards is actually the task we're going to do. Eventually, you're going to be writing your own word problem, okay? Not for a system, but for a system of inequalities, all right? So that's where we're going for the performance task. We're going to work on setting things up. So, steps for solving word problems. All right, I think you have to fill in some blanks, right? So there's the first one. Indicate what each variable stands for. Or is that already in there for you? It's already there? Awesome. Okay. Maybe underline or highlight the word that I bolded there. Write a system of two equations that can be used to solve the problem. So you got to decide what the variables mean, write a system of equations, solve the system, and then state your solution in sentence form. Okay? I'm not so worried about you putting your back in sentence form, but you should probably label something because it is a word problem. Okay? Okay, so we've got Chase and Sarah went to the candy store. Chase bought 5 pieces of fudge and 3 pieces of bubble gum for a total of $5.70. Sarah bought 2 pieces of fudge and 10 pieces of bubble gum for a total of $3.60. How much does 1 piece of fudge and 1 piece of bubble gum cost? So this is a fairly typical problem. They give you something about money, okay? In this one, the way that I would do this one is I would write a Chase equation and I would write a Sarah equation, okay? So let's talk about Chase's equation here. Actually, before I talk about that, I'm going to talk about my variables. I don't have to use X and Y, okay? In fact, sometimes it's easier if I don't. I know that there's a fudge and a bubble gum, right? So I have to tell the person who's grading it what they stand for. So I'm going to say F stands for fudge and B stands for bubblegum. Okay. So I'm going to write a fudge and a bubblegum equation. All right. So for Chase, how many pieces of fudge did he have? 5. So 5 fudge plus how many pieces of bubble gum? 3 bubble gum. So 3B, and he spent a total of what? 570. So could I just write 5? Oh, I could write 570. That's fine. You don't need the 0, but that's fine. Okay, now let's write a Sarah equation. How much fudge did Sarah buy? 2 fudge plus how much bubble gum? Apparently Sarah likes gum. And that equals a total of how much? 360. All right. From this point, we've got the system set up. That's usually the hardest part, is setting up the system. Once you've got it set up, you get to pick. You could do graphing. I wouldn't recommend it. Okay. We could do substitution. We could do elimination, or we could do Kramer's rule. What would you guys like to do? Okay. Ironically, that's what they did last year too. Okay. So I'm looking at last year's notes. They did Kramer's rule. And again, the numbers are kind of ugly. We've got some decimal points. Kramer's rule might be our best shot, right? So let's do Kramer's rule. It's perfectly fine. So I've got to solve for the fudge, and I've got to solve for the bubble gum. I didn't leave myself a whole lot of room to do my work, did I? I'll write this one tinier. Okay, so I'm gonna make that one tinier because I need more space for my work. Okay, so what would my my fudge column be, or my X column? 5, 2. Okay, what would my bubblegum column be? 3, 10. All right, I'm solving for fudge, which was like the X coordinate, so what's going to get shoved upstairs? 310, and what's going to go in for the fudge? Yeah, and I don't need the zeros at that point. All right, looking at my bubblegum. Bubblegum, remember, is the second column, so what's going to get shoved upstairs? 5, 2, and for the bubblegum column, we're going to put in? Good. Okay, let's do the denominator first, make sure there's an answer for it. So what's 5 times 10? Minus 3 times 2 is? 6. I'm going to go across because I'm out of space. You guys can keep going down. So we get 40 what? 44. So I know the denominator is 44. Okay. Let's do the numerator. So what's 5.7 times 10? 57. Minus is the operation. 3 times 3.6? 10.8. Good. And subtract 57 minus 10.8 is? 46.2. Good. And it would make sense to put it in decimal because we're talking about money. So what's 46.2 divided by 44? 1.05. Good. So we know that that would be $1.05 for fudge, right? So we'll write that out here in a second. All right. What is 5 times 3.6? 18. Good. Minus, what is 2 times 5.7? Good. 18 minus 11.4 is what? 10.6? 6.6. 6.6. Okay, and then divide that out. What do we end up with? 0.15. All right, so, which kind of makes sense, right? Bubblegum should be way cheaper than fudge. All right, so we would say that fudge costs $1.05 and bubblegum should be one word, costs 15 cents. Is that a proper sentence? Not really. Okay. But you need to at least kind of tell me, summarize your answer there. Okay? We've only got 4 examples today. Nice. Yeah. Then you get to start the assignment. Isn't that exciting? All right. The Frosty Ice Cream Shop sells sundaes for $2 and banana splits for $3. On a hot summer day, the shop sold 8 more sundaes than banana splits and made $156. Okay? How many sundaes and how many banana splits did they sell? So this one is weird where we're getting the stuff from. It doesn't look like we just, like the last equation, we were able to put all of Chase's information in an equation and all of Sarah's information in an equation. We can't do that here. But I do see a common theme of money, right? I see money for sundaes, and I see money for banana splits, and I see a total amount of money. So I think I could probably make an equation out of that. What do you think we should use for our variables? S for our variable for Sunday, right? Okay. And what is the B stand for? Banana splits. Again, if you like X and Y, that's fine, but you need to tell me what X equals and what Y equals. So you always assign the variables first, okay? All right, let's write a money equation. So how much were the sundaes? $2. So 2 times the sundaes plus how much were the banana splits? $3 times the banana splits equals a total of how many dollars? $156. Okay. The other equation, we got to be a little bit more careful. The shop sold 8 more sundaes than banana splits. So that means they sold how many? So it's the sundaes equals the banana splits. What is more? What operation? Still haven't guessed the right one. Okay, so there's these 4 operations, right? More would be what? It's got to be addition, right? So banana splits plus 8 equals the sundaes, right? So whatever you sold on your banana splits, 8 more, they had 8 more Sundays than that. All right. This one's pretty well set up for which type of systems problem. It's the substitution problem, right? If you wanted to go back and set it up as an elimination or Kramer's rule, you could, but I'm going to go ahead and do the substitution on it because it's already set for that. I'm taking this and substituting it in for the S. All right, so I'm going to do 2. I'm going to write a parentheses plus 3b equals 156. What's going to go in the parentheses? Good. All right, what are we going to do with this 2? Good, so we've got 2b plus what? Plus 3b equals 156. All right, what's 2b plus 3b? 5b. And at the same time, what are we going to do with this 16? Good, what's 156 minus 16? And what are we going to do with the 5? Divide it. So it's 140 divided by 5? I think I heard 28, right? So 28 banana splits. How am I going to calculate Sundays? Plug in. Do you want to plug into the first one or the second one? I'd go second one, right? Because it's already solved for us. So Sundays equals 28 banana splits plus 8. So how many Sundays did they do? 36. Good. Let's conclude it a little bit. Let's give it a little bit of an ending. So we know that they sold 36 Sundays and 28 banana splits. That wasn't a true sentence, but at least it kind of gives it some kind of a conclusion there for us. All right. Let's look at the next one. What?
I thought a Sunday was a banana split.
No. A banana split is you cut the banana in half and you have 3 scoops of ice cream, typically like a Neapolitan kind of thing, right?
Yeah.
Vanilla, chocolate, strawberry, and then they throw stuff on top of it. A sundae is typically like ice cream, hot fudge, and toppings. There is a difference. I think this weekend you need to go to Baskin-Robbins and order a banana split and see what you get. And order a sundae and see what the difference is, right? Tell mom and dad it's research. Research, right? Okay, so Miss Kitts works at a music store. Last week she sold 6 more than 3 times, so they're really getting tricky with us now. 6 more than 3 times the number of CDs than she sold this week. Obviously, this problem's a little outdated, okay? But we're going to go with it. Miss Kitts sold a total of 110 CDs over the 2 weeks. How many CDs did she sell each week? So in this case, it looks like what we're looking for is weeks, right? So I'm going to go with X and Y because I don't want to use W and W. So I'm going to use that X equals week 1 and Y equals week 2. We still need a variable, so we've got to get, whatchamacallit, we have to assign them. All right, let's see what we can do with this. It says last week would be week 1, right? So I'm going to write that up there so I don't get confused. She sold, so week 1 we said was the X. She sold 6 more than 3 times the number of CDs she sold this week. So this week would be week 2 or Y. All right, so it says last week she sold. That indicates equals to me. So X equals 6 more than. What operation is 6 more than?
Addition.
Addition. So I know I'm going to have a plus 6 in there. 3 times. What operation is that? Multiplication. That's pretty obvious. And then times the other week, which would be our Y value. Okay. Now let's look at the next thing. Miss Kitts sold a total of 110 CDs. So we need to basically add up the number of CDs she sold in week 1 to how much she sold in week 2 and set it equal to what? 110. All right. What type of systems problem is set up here? Substitution, elimination, Kramer's rule. It looks like a substitution problem. So I'm going to take this and I'm going to substitute it in here for the x. So here's what I want you to do. I want you to take a minute and try it. Okay, so everybody is trying that problem right now. All right, let's check it. So I'm plugging in what for the x? 3y plus 6. Okay, I don't really need the parentheses, so I'm going to combine like terms. So it's 3y plus y. 4y. And then what are we going to do with this 6 to move it to the other side? Good, what'd you get? 104. Okay, what are we going to do with the 4? Divide it. What do we end up with? 26 for week 2. How do I get week 1? Plug in. Where am I going to plug in? The first one or the second one? Second one? First one? Okay, first one. So 3 times 26 plus 6. All right, what's 3 times 26? 78 plus 6 ends up being what? 84. So we would say that week 1 sold 84 CDs and week 2 sold 26 CDs. Probably need to change it to downloads, right? Okay. Let's take a look at example 4. So this one, and they like to throw a little geometry in here every once in a while, okay? So the length of a rectangle is equal to triple the width. What are the dimensions of the rectangle if the perimeter is 86 centimeters? All right, so what are my two variables going to be?
Length and width.
Length and width. So L for length and W for width. Okay. What are the dimensions? So we've got the length of the rectangle is equal to triple the width. Okay, so I would personally be drawing a picture for that. So I know that the length equals triple the width. So what kind of an operation is triple the width? 3 times, right? It would be that. So if the width is W, the length is 3 times the width. Okay. So that's kind of one of our equations right there, isn't it? All right. Then it talks about the perimeter, doesn't it? So that what are the dimensions of the rectangle if the perimeter is 86 centimeters? So how do we get the perimeter? Add all the sides, right? So I would add the length plus the width plus the length plus the width, right? Let me fix that. The length plus the width, because this would be the length and that would be the width again. And that equals a total of what? 86. Could I simplify that a little bit? Yeah, so how many L's do I have? 2 L's plus 2 W's equals 80. I don't know why I'm changing to 88. 86. Okay. So, what am I going to plug in for the L's? What did we decide? 3W. So 2 times 3W plus 2W equals 86. What's 2 times 3? 6W plus 2W equals 86. So what's 6 plus 2? 8W equals 86. So I'm going to divide by 8. What do we end up with? 10.75 sounds good. And then in order to get the length, what am I going to do with the 10.75? Plug it. I'd probably use that 3W, right? So 10.75 times 3, and we end up with what? 32.25. We were measured in, it said centimeters. So we would say that the dimensions would be 32.25 centimeters by 10.75 centimeters. Okay. So